How much does oil weigh?
7.5 pounds per gallon.
How much about per quart? Great. Great, great. 1.8, la 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 la. So, when asked what moment is, how would you describe a moment?
Force at the station.
Very good. A force. And it's in what? How do you say moment?
Pounds per inches.
Pounds, inches. Let's see. That's too easy a question. What's included in basic empty weight?
The fuel.
Full engine liquids.
There you go. Weight of airplane, optional equipment, unusable fuel, full operating fluids that include engine oil. So you are aft CG. How's your airplane going to handle? Christian?
It's going to be less stable, and so you're going to have faster cruise speed and low stall speed.
And why faster cruise speed?
Because there's less tail drag.
Less angle of attack needed, right? Less tail down force, all that stuff. So forward CG, AJ.
Opposite what you just said.
True.
And then, was it slower cruising speed? And we're not going to handle as well. It's going to be more unstable. No?
Look at the door that I drew. Forward CG, we have a longer arm.
More stable, less efficient.
There you go. That's a perfect way to say it. More stable but less efficient. You probably could get away with that. That's pretty darn good. Heavy, you're flying heavy. Tony, how's that airplane going to handle?
Longer ground roll,
Mhm.
higher speed, and a higher stall speed.
Need a higher angle of attack. So not really stall. It's going to be harder on your airplane. Angel, when you see this, what's the best way to do this problem?
Do the math.
Do the math, yeah. So where are you going to go for the arms?
At the top of the
Good. Let's see. So let's get into reviewing this one and then the weight shift one. So page 214, 215 in the Gleim, then we'll move into performance. Even throw in another one. So see. Christian, who's your study buddy? Okay, I already picked on both of you. So, Seth, your study buddy is Juan.
Christian is too ashamed to admit that.
Okay, so let's have, we're just gonna skip the study buddy thing. Let's have Juan and Seth do on the board, problem on 214. a lot of work. Wow, oh, no worries. So which one or both of you want to explain it?
Okay, sure. Okay, so we're giving all the weight, except for in the problem, we're giving all the weight except for the basic impute.
Yes.
And then, we're only giving the fuel in gallons, but we determined yesterday that, 1 gallon of fuel is 6 pounds, so that's how we got that, so that's all our weight. We found the R's over in figure 67, the fuel R is right here, 75 inches, occupant, front seat, 85, rear seat, forward, 111, and then back seat, 136, baggage, starts, or the arm, sorry, is 50. But that's also where we got that 1%. So I'll also give the in the chart at the top left. So, so you just multiply, of course, to get our moment, and then this is where we got this number. So after we added it all together, we got our total moment, our total weight. So we divide our total moment by our total weight to get our CG. And then in the gross weight moment limits in the bottom left, you can see that the maximum, we got 83.5 on the bottom, up to the top. The top is at 3,400 pounds, and we're at 3,203 pounds, so 197 pounds under the max weight. So let's then write that up. So there's the weight that we're under, and that's our CG. And that's what option 8 says.
Very good. Again, a lot of work. And you used your CX. So how many do not know how to use your CX or your Sporties? Keep in mind, you can't use your phone when you're in the written. Can't use your phone for phase C. Really good, Seth and Juan.
Thank you.
Okay, so let's do two more. Let's see, 208, 206, 207. So 206, let's have Kurt and Nick. You want to do it on the board?
Up to you then. Sure.
Those of you working on your 90s, have you gotten a weight shift in your question? Has it been one of these two? Or did you actually?
I want to say it's 1 on 206, it's the one on top.
Okay.
I have that one
That one was
You did too, Angel?
easy. The next one,
Next one's a little more complicated.
The next one's like,
Yeah.
you can't really figure it out on your own. Like, you have to know how to do it.
Yeah, they complicate it with that darn plank. So we'll have Angel and Tony do the one on 207. Did you meet with the instructor today?
Oh, today?
Yeah.
No.
No, Tuesdays and Thursdays.
He sent me a message that he's flying today, but any time next week. I send a message that I can see him anytime next week in the mornings. Alan is so nice guy.
Yeah, he is. He really wants to help. So it's really good. Did you call Orman Aircraft? Did you call the Orman Aircraft?
No,
about
not yet.
Union? I haven't seen him yet.
Because I'm talking with my mechanic.
Oh, are you?
He said, "Oh, okay, I'm trying to find some way to."
You don't want to leave it.
Yes, that's it.
Well, that's
Let me show you. It's old stuff for my plane.
Mm-hmm.
This license empty weight.
oh
It's without oil.
yeah,
believe
because that's
because they-
license empty weight.
Yeah, license is without oil. It's a new. No,
Oh,
it's
that's
an old.
That's
so-
old. Easiest basic empty weight.
Yeah, yeah.
I'll be darned.
But it's not basic because basic I have just a little oil or no.
Oh, you have to add the oil. What's your airplane hold 6 quarts? If you usually put probably 5 in it,
Yes, 5 in it. Yeah, the maximum is 6 quarts.
so 5 times 2 pounds,
Yeah. it's
so
12.
10 pounds.
10
Yeah,
pounds,
10
yeah.
pounds. So you add 10 pounds to your
They
weight.
tell me to use 8 quarters. I don't know why, because normally full oil may be assumed for. My plane is 8 quarters. Yes,
Is it?
yes.
I'm pretty sure these. What kind of engine do you have?
It's a 0300 6 cylinders.
Oh, 6.
Yes.
That's fine. So this is your Bonanza.
No, my season.
You have a 6-cylinder in your
Yes, the last season was produced with 6 cylinders. 67. It's a Continental 6 cylinder.
What's your top speed?
Mm,
That's a fast 172.
yes, because it's light.
Yeah.
But it's not so. I don't have too many power. It's 145.
That's good. I'm not sure what their horsepower is. That's really good. It's a good Cessna. I'm watching Seth and AJ on this one. You ready?
We're figuring out where to put it. So what would be the weight times the arm, and arm is something we don't know.
So I think we're ready.
So divide by 5%.
Ready?
And then you want it to equal.
So 206.
equal this thing. Okay.
Okay, so Nick and Kurt is going to explain 206. Question
Try
on
to explain it the best way I can. Basically, the left has to equal right in order to be balanced. So we know X is 50 pounds, 50 inches. And Y, we don't know how much Y weighs, so we're just putting Y for now. At 25 inches. And that must equal
So-
100 pounds or 100
So we have
inches.
enough full from here, and we want it
So,
to be balanced.
do your math, 50 times 50 is 500.
And it's centered there,
100
like,
times
like,
100 is
it's
10,000.
anything.
So then we still have 1 over
So
25.
that's how we figure
So
out.
subtract 2,500 from either side, and it's cancel out. Value of 7,500.
So
We still have 1 over 5. Divide each side by 25. 5 cancels out, and that equals 300.
Good.
Well,
It's really basic.
you spoke at the end, but anyway,
Seth, elaborate.
so it should be Y over 25, it should be Y times 25.
Should be Y times 25.
So the second to last step, you should divide both sides of that by 25. Because Y over 25 over
How
25
do we
would
get
be like Y over something.
So that means
Right, over Y times 25.
It's not, it's basically equals 25 inches. Y equals 25 inches, you just don't have the other number. You know what I'm saying?
Yeah, so it'd be Y times 25.
Yeah.
But
We're not dividing Y into 25.
now, you're dividing Y by 25.
And then you just.
So you're saying that Y times 25, Seth?
It's, Yeah, I think it's just the way they wrote it.
Yeah.
Because you're not, or up there, you're saying it's Y divided by 25.
Yeah, we're not dividing.
Yeah, so it's just the way you wrote it. Yeah, it's slashes.
Okay.
Yeah.
Okay. I
So
guess it would be
just
just like
like
you
that.
do, Y over 25.
Yeah, yeah, they just put parentheses.
Yes.
Okay.
Yeah.
Yeah.
Yep.
Yeah, we're not, you can't do that.
Well, yeah. Okay.
Everyone got it? Okay, good, Kurt and Nick. Okay, April and Angel and Tony. 207?
Oh, okay. I'm with you, man.
Way up there. All the way up there. You want to erase that one? Yeah.
So you just set it up with an equation.
This is probably the hardest out of the 3 questions today. 207.
5,000.
Ready to explain?
Well, these are the weights, these are the inches. So, I can't explain it that well, but
You're doing great.
work out the math.
He said one side of the bowl equals the other side.
Yeah, you always have to have
Okay.
one equal the other. So what you do to one side, you have to do to the other side.
Directly under the equation, x equals 16, how did you get that?
It was.
Well, it's doing the math, it's doing the math.
Okay, gotcha.
So what's the answer? Okay, so we got 16 inches. So how do you figure out?
Left because it was at 15 inches.
So can you explain why left?
Because it's further in the middle.
Does everyone understand that? Okay. Did you do this on your flight computer or in your brain? Worked it out, okay. So everyone understand it?
I just have one question. Agent explained it to me, and I feel pretty good about it, but I just want to double check. So the 200 times 15, obviously the 250 by 20, we get that from the weight. How far away it is from the new fulcrum. But the 200 by 15, that is the total weight of the plane times the difference between the old center of gravity to the new center of gravity.
It's not, you're not moving center of gravity, it's the center of gravity is where the weight is acting. So if that whole plane goes to the house and the center of gravity is right in the middle of the plane, which is 15 inches from the fulcrum. Does that make sense? So the center of gravity is in the middle of the plane, and that's where all of the weight is focused. So if you have just the plane, it would go from the there with balance. But since the fulcrum is here, the center of gravity stays in the same place, so all that sort of counts is right there. So the arms are actually counts 15 inches.
Alright.
Does that make sense?
Everyone understand that? Nick? Kurt? Good? Okay, good job. That was a hard one. That was a hard one. Someone tall, if you would erase that, otherwise I'm gonna have to pull a chair up. Remember, I'm a shrimp. Thank you. Really good job. Tomorrow we start our day same way. I'll write the assignments on the board. Only it'll be performance. So any questions before we move on to performance on weight and balance? I think we're ready to move on. So our goal tomorrow will be to review the performance assignment, homework assignment, and then start navigation. Again, I'd really like to get into navigation, so those of you that have gotten your 90s, if you want to take your exam, we all feel good about it. So I don't think we need to review this. Performance is based on these standards. Review of airspeeds, indicated, what you're looking at, calibrated, corrected for instrument error, true, corrected for temperature, and ground speed, corrected for wind. Altitude. How do you feel about this, Angel? Good? You're the one that helped me explain it better. So indicated what you're looking at on the gauge, absolute above the ground, true MSL, pressure, a measurement from that imaginary line, density, moisture, and temperature. High to low, look out below. So it applies to a high pressure or a high temperature going to a low pressure or a low temperature. You don't set your altimeter, you're going to be off altitude. Doesn't matter if you're going low to high or high to low. You don't set your altimeter, you're going to be off altitude. When you look at the questions, how many of you have gotten pressure altitude questions? No? You one? If you don't look at the question and you don't ask yourself, we went over this when we were in instruments, but that was like your second week with me. If you don't look at the question is about your airplane being high or low or the altimeter being high to low, you're going to get it wrong. Two totally different answers. You can see a high to low on an airplane question. So the airplane in a warmer temperature is higher than an airplane in a colder temperature. Same type of question, an altimeter in a warmer temperature. Let's see, so it would be the altimeter would be reading higher. So the airplane would be lower. If it's an airplane question, the altimeter would be higher because you didn't adjust it. You gotta look at what the question is asking you. Okay, Juan? I see you going, it's hard. Good. I don't think we need to review this. Humidity? Mm-hmm.
That one, alright. I need to read that again because I had one of the questions and I've muddled it up in my mind again. It was basically asking if, I can't even remember. I don't know.
Taking off a high altitude airport?
Yeah, so basically asking if your efficiency was going to decrease or increase and why in relation to the propeller working harder.
Efficiency.
How it said it.
Oh,
I
boy.
just muddled it all up. There was two things that I had to flip in the question in order to get it right, and I only took one. Yeah.
Any of you ever get a question that muddles your mind, try and do a screenshot and bring it in, because it's going to muddle everyone's mind.
Glad you said that.
Yeah. Did you do a screenshot?
I may have, but many screenshots.
Because you know, if it muddles your mind, it muddles others' minds. We're getting down to the wire, so let's unmuddle things. That's how we start all classes, is reviewing what's muddled. Higher altitudes, the air spreads out. The oxygen spreads out. So it's going to be less efficient. You add humidity and temperature to it, it's going to really be less efficient because then those air molecules are going up even faster. You have even less air molecules around you. That's too bad. See if you can find it tonight. It'd be good to start. So pressure altitude is that imaginary line, 2992, and we measure the pressure of whatever the atmosphere is by that imaginary line. So density altitude, corrected for non-standard temperature. Called the 3 H's. High altitude, hot air temperature, high humidity. Extremely less performance. You start out, let's just say 6,000 feet, with less air molecules around you. You add hot temperature, air molecules rise even quicker, even less air molecules. Then you add moist air molecules, and you have tripled the amount of air molecules.
I have a new teaching tool I think you might like. Just came out of behind the PFD. It's an INOP cooling fan battery for it. And that died, so the PFD started overheating and shut off. So that's what you're listening for when you check it.
I'll be darned. This little whirl?
Yeah, that little guy right there.
Yeah, I'll be darned. Thank you very
That's
much.
all yours.
Okay. So a PFD quit working?
Yep, because it got hot because that was broken.
Okay. Did the MFD continue to work?
It did, it backed it up.
Okay, that's really great. Thank you. So did you understand what he just said? They know I love toys. So, and one of the reasons I asked is because when the citations PFD and MFD went, except we didn't have any little whirly noise, and they came back up in 10 minutes. So that's really cool. Do you understand what it is? Mhm. Good? That's cool. Okay, where were we? So the 3 H's. So let's watch our density altitude video, then we'll talk about region of reverse command. Has anyone ever heard of that? Region of reverse command. I didn't hear about it until I started my flight instructor certificate, but it's up here because one student got that question on a written. Yeah, but let's get density altitude in our brains first, and the 3 H's.
As was experienced from the right seat inside the cockpit. The accident took place on Saturday, June 30th, 2012. At the time of this reported information was preliminary, subject to change, but some had history. The aircraft was Gibson Model 108-3, generated 165 horsepower single-engine high-wing propeller-driven aircraft capable of carrying 4, plus full fuel and light baggage. The aircraft's performance is dependent, among other things, on the density of the air it moves through. The aircraft appears to be operating from Bruce Meadows Airstrip, a 5,000-foot-long dirt and grass airstrip situated at an elevation of 6,370 feet, surrounded by 8,000 and 9,000-foot mountain peaks near the town of Stanley, Idaho. That may be important. Watch what happens here. What she just saw was the aircraft skipping off the ground after having previously become airborne, only after prolonged ground run. The aircraft seems unwilling to climb. Not speculate as to the cause of the crash, but it may nonetheless provide a good example of what pilots call a high-density altitude takeoff. Cold, low-altitude air is more dense, it's thicker than air found at higher altitudes and/or higher temperatures. Moisture in the air, humidity, displaces air molecules and also acts to thin the air. For the pilot of a propeller-driven aircraft, cold air has its benefits. It gives the surfaces of the aircraft, the wing, and propeller more cushiness, as it were. It naturally aspirates the non-turbocharged engine, more air molecules to mix with the fuel. That results in higher power output. Here, the NTSB has collected air data, including barometric pressure, temperature, and moisture for the accident's location on the day of the crash. Figures show that while the aircraft was physically located at an elevation of 6,370 feet, the air around it was as thin as that found at 9,167 feet on the standard day. In other words, compared to a cooler day at a lower altitude, the engine of this aircraft had less air to mix with fuel, it put out less power, while the propeller moved less air and produced pilot was attempting to climb, this particular aircraft appeared strained at best and unwilling at worst. Whatever it calls, this was the result. All four men involved in this accident walked away. Early reports state that the pilot suffered the worst injury, including a broken jaw. Shown in slow motion, you get a sense of how the airframe absorbed energy. Each impact with the tree lessens the amount of energy left for the final impact with the ground. The occupants were lucky. Once over the trees, there was very little the pilot could do. Faced with low airspeed and rising terrain, the turn was out of the question. At that point, riding it in might have been their best and only option. Q for Adwin.com.
So it's reaching a point now where it's going to start heating up in Florida, and the humidity is going to start picking up. So ATIS is going to start calling density altitude. We're at 10 feet, MSL. Density altitude could reach almost 2,000. So the airplane's going to think it's taken off at 2,000. Very serious stuff. So what kind of hazardous attitude did that pilot probably have?
Vulnerability.
Invulnerability. One more maybe. Macho. You know, he'd owned that airplane for a long time. I can do it. No issue. Didn't pay attention to density altitude. 6,000 feet. That's hard on. That's hard on any. Yeah.
There was a lot of time there if he was just over flat
Yeah.
ground and he
Totally.
didn't land.
And that first bump should have
Yeah.
said, "Ooh, something's not right." You know, all sorts of warnings there. Not good. The what? For adults. Yeah, and it's kind of like you're starting off bad if you were at sea level. Not good. Okay, so normal command. Normal command. So altitude, airspeed. Region of reverse command, airspeed, altitude. So it's opposite. Juan, did I say that not right? He's going, okay, so region of reverse command, Juan, how would you describe that? Airspeed. How you doing? You're what?
Average.
Okay, you don't look average. Okay, well, 12?
In a row.
Weather? Sucks. Sucks.
No.
So, how are all of you feeling about your CX? Bring it on? Okay.
I'll get my 6-3.
Okay. So, region of reverse command. So, airspeed, altitude. When do you do this for airspeed, this for altitude? Yeah. Well, slow flight, when you're low, slow. When you're practicing, when you're landing. You know, so especially short field landings, but when you're landing. So that's called region of reverse command. You're going to have one student get that question on a written. So it's not that complicated. You got time? You'll get there. You're down to the wire. You've got quite a bit to do, so it might be a good thing. Why don't I talk the density altitude chart? You could show how to do it in the CX. Does anyone know how to do this in the CX3? Especially you detailed students. Some of these performance charts will drive you bananas because they're not accurate. They're a guess. You know how? Density altitude, this is right from the glide. Again, your homework, I'll pick from 188 to 199 different types of tricks. And that's how we start tomorrow. So density altitude, pressure altitude corrected for non-standard temperature, what the airplane thinks it's flying at. If you're using the chart, let's read the example first. Airport elevation, we're taking off at 5,883 feet. We have an outside temperature of 70 Fahrenheit. Altimeter's 30.10. First thing you have to do is you have to come over to the conversion table, except for one question. It's probably the one I'll pick tomorrow. So you have to come over to the conversion table. You'll find 30.10. Your questions could very likely be in between. You're going to have to interpolate. So we got to subtract 165 from our airport elevation. Gives us 5,718 feet. That's where we're going to. And you have to look at the slidey lines. This is what will drive you detailed students crazy, because we're going to guess it is right about here. So we come up from our 70 Fahrenheit. We go up to the slidey line about where 5,718 feet is. We come over here. We're going to estimate we have 7,700 feet. Disadvantage of getting the exact with your CX3 is that you're going to have two answers that are very close together. Your CX3 gives you exact. That's the disadvantage. Some of the questions you may have to use the chart. You ready? You want to share how you do this on your CX3?
We don't really talk how to do it, but I'm going to share the method behind what we
So, is that? Oh, okay. I was not expecting this today. Essentially from the CX3, I'll just start over. So each page, it has a few, I would say, points of information where you can insert and it will give you answers in total, right? So with the question marks, essentially it's just asking you, I should put in something, and then once it gets a green tick mark on the left-hand side of the information, it means you put in that thing, and the equal sign in green is what it calculated. So literally for every single page on the CX3, on the flight portion of it, which is the FLT button in the top left, literally it's just bits of information. You put in 2 or 3 pieces, it calculates the rest. And that's how you go about doing the whole GLIME questions. So essentially, in the case of this one, they'll probably give you something like for example, in Julie's question, they'll give you airport elevation, outside air temperature, and altimeter. Or in some cases, they'll give you density altitude and ask you to work it backwards. So it's just pretty much the exact same option. Putting in the 2 pieces of information, it gives you the last, third, and fourth options as the answer. And that works for all the pages when you're calculating performance, not just weather, cloud bases, wind correction, deviation, and everything in total. But for most of you, from what I've seen, you're able to work out this one in BASIC. But the trick is, look for key words or key topics in the question itself, and that's how all the pages are labeled essentially. So this one is talking about altitude. So essentially you go to the altitude page. If it was talking about wind, you'd go to a page that says wind in the title. If it's talking about magnetic heading or compasses or just anything with direction, you go to, what is that page? Magnetic heading page. So essentially it's just all about figuring out which page to go through based on the topic that you get on the question. And that is a basic trick to go through most of the GLIME questions. Yeah, that should be it, unless they have any more questions about specific pages.
Or anyone stuck on a GLIME question that requires CX3 but not sure how to? Okay. All right, for the example, oh yeah, I think you were not in it, but essentially when you turn your CX3 and you go to the FLT and altitude, so then one of the top pages is altitude.
Yep.
So once you enter it in, essentially it's just put in 2 or 3 pieces of information and it brings out the rest of the answer, and you should have something close to 7,700. This will be more accurate, so it's just a matter of like looking which of the 2 answers is closest to what the CX3 says. Yeah.
There's the specific GLIME questions that came up, and it was like, okay, I don't know which page to go through in order to get that answer. And I can't give you the example right now because I can't remember which one it was, but I see I'll either screenshot it and write it down, and then maybe you can.
Yeah, sure, no worries. I'm always up and about in the library. So, but yeah, essentially, it's just, the basic idea is just find something common in terms of the question, like a major topic. If it's altitude, look for altitude on CX3. If it's heading, look for heading. Wind, look for wind, and so forth. Weight and balance. There's a weight and balance section, but that's a topic for, I think, a later time. Yeah. And now I'll come to help you guys out and show you a bunch of tricks for weight and balance in your aircraft and weight and balance on the GLIME.
Oh, I'm not sure I wanna.
As a pilot, it is your responsibility to know the performance.
Well, if you want to see that, it's kind of long, but it's not bad. So maybe tonight, if you have questions, take a look at it. Let's see, what can I do with this little guy? It's really not that bad a chart. It's just not accurate. How many have gotten this one? Do you know how to do it? It's not that hard. You can't do it in your CX3.
It's like, I know how to do it, but it's really annoying because I want you to be super accurate with the answers, but the way the graph is designed is not
It is.
accurate.
That is the most annoying is a very good word, especially for students that get the math.
They're like, is it 8,000 or is it 8,200?
Yep.
I don't know, they're this far apart.
Yep, that's, you know, the students that really know math really detest it. It's kind of like doing this one by the graph. You know, you can get exact in your CX3. This one you can't really do your CX3. Mateo tried finding it, it just doesn't work. So if you understand how to do it, we'll just briefly cover it. I think I just unplugged myself. The first thing you do, and I don't cover landing graphs because it's the exact same process. Tomorrow we will do it 1 takeoff and 1 landing. So I'll pick someone to do it. Yeah, but it's not that hard because the first thing you want to do is think that these are 4 different graphs. You're given information in a problem. The information on pressure, altitude, temperature is on this graph. The hardest part of it is trying to be accurate on the slidey lines. Because with this one, in the problem, let's see, I didn't put it up here. In the problem, we have 22 Celsius. We're given 2,000 MSL. So we go up to find 22 Celsius, go up to the 2,000 MSL. That's all you need from this graph. As soon as you have all the information entered, you go straight over. This is when those plastic overlays for your exam and your phase exam really work. Or piece of paper or plotter, something so that you can really follow it over. We're given an aircraft that weighs 2,600 pounds. This is really where students mess up. The slidey lines are hard to follow. Wherever you enter, the closest slidey line is what you need to follow down. It is. It's hard. It is really hard. So let's just say we came here. So we follow this one. Let's just say we were here. So we follow this one. So the slidey lines, especially in the weight, because you're going to be given a weight that is like, let's just say this is 2,500. So you got to go straight over. You can't even go down. If you're right at max weight, you got to go straight over. You can't go down. You're there. Yeah, it starts right here. So that messes you up. This is the hardest one because of the slidey lines. So now we have our 22 Celsius, 2,000, we're done. Now we're given in the problem 2,600 pounds. So we're close to this line, we follow it down. We're done. We're done with all the information we can do in this graph. We go straight over. You have a tailwind, you go up the dash lines. If you have a headwind, you go down to the closest line that you're close to. Just happens this one comes in on a line. If you're here, then you gotta follow it down. So it really depends on the line that you're close to. So we're given a headwind of, it looks like about 8 knots. So we come down to the 8 knot. We're done with that graph. You go straight over. If the problem does not state 50-foot obstacle, you don't have one. It has to say 50-foot obstacle. If it says 50-foot obstacle, whatever slidey line you are near, you go up. This one doesn't look like it's very accurate. Yeah, it's not very accurate. If you don't have a 50-foot obstacle stated in that problem, you just go straight over. If you have calm wind, wherever you entered this particular graph, you go straight over. Yeah. So calm wind is straight over. No 50-foot obstacle, straight over. So if you look at this as a whole, your brain melts. If you look at it as 4 different graphs and just use the information that you need, do your best, bless you, to follow it down. It's not so hard. The best way to do it is just practice the glide. Tomorrow we do 1 takeoff, 1 landing. These hurt me real bad when I was a student pilot. I remember getting 1 on my FAA written. Didn't get it right. Yeah, it hurt me. I totally didn't get it. This one hurts me. Cruise performance. It's a real chart. It's a Piper, constant speed propeller. So it's really the FAA wanting to know if you can do math. That's all it is, because it's going to be in tripulation. You're going to have to find the difference between something. So we want to know fuel consumption on a 500 nautical mile flight. We're given pressure altitude of 4,000, temperature of plus 29 Celsius, manifold pressure, because it's a constant speed propeller, 21.3 inches, winds calm. It's all charts and graphs. You have to read all the information. So the gray area is at your full throttle. That's all that means. Let's see. So we have we are 4,000. Let's follow 4,000 over to 29 Celsius. So made it easy. We have calm wind. So on a 500 nautical flight, what is our fuel consumption? So I lost my line. So we have RPMs, manifold pressure, so it all matches. So we are going to burn 11.5 gallons. So if we're burning 11.5 gallons an hour, we're on a 500 nautical flight, so now we just need to do the math. So how long is it going to take us? True airspeed of knots, 159. So do the math. Use your flight computers. And then I'll tell you where the trick is on this one. It's a math problem. And tomorrow we do one of these. Does everyone get that?
What? The question is how long is it going to take?
No. What's fuel consumption?
Oh.
500 nautical miles. We're burning 11.5 gallons per hour. And you got to know how fast we're going. We're going 159. Or did I follow? Yeah, 159 knots. So you have to enter all of it. Yeah, you can do it in your CX.
5. So we will burn 36, a little over 36 gallons.
What'd you get, Kurt?
Yeah, it's just simple math.
36 it is. It becomes a math problem.
Yeah.
Pay very close attention if the question is given knots or miles per hour. Because they'll give you sometimes miles per hour. They're going to say, what are you doing in miles per hour? And you're not going to pay attention, you're going to give the answer in knots. Usually that's where students get it wrong. Because you're going to have a different type of question that's asking you, giving you miles per hour, and then you have to figure out another type of problem using this chart. Is that what you're doing, AJ? Figuring out miles per hour? Mm-mm. And it's going to be an interpolation too, because they're not going to make it that clean. They'll probably give you like pressure altitude of, just for example, 4,500. So you're going to have to figure out the in-between of everything. If you can do your CX3, it makes life so much easier. You know, do you have a CX3? Okay. Do you plan on using that in your written? Because I can ask her if you're allowed to use calculators.
No, it is.
Yeah, but some students prefer not a CX3. Some students prefer a calculator. Okay. So we'll do one out of the Gleim tomorrow. Crosswind component. Those of you practicing very intently on your 90s, how many got a crosswind component? This is real life also. It's going to be part of your check ride. It's not that hard. Again, you'll look at all the information there. So maximum demonstrated crosswind is 15 knots for this airplane. The problem I picked out of the Gleim is not this easy. We'll do that one tomorrow. So the first thing you do is that you take the given wind and the runway. So the runway is 70, the wind is 30. You subtract the difference because this is crosswind. except for the one problem that I'm going to pick tomorrow. You enter it on the difference between the runway and the wind line. That's what this line is for. So you enter it up here. These are your wind velocity arcs. So we have a difference of 40 degrees, 15 knots. We go to the wind arc knot. Go down. We have a 10-knot crosswind. It's that easy. Students forget that you have to subtract the runway from the wind direction, and you start up here. That's it. Go to the wind arc, come down. If it's a question on a headwind or a tailwind, you go that way. With this one, you don't have a choice on a tailwind. It's a headwind. So we have a headwind of, what is that, about 12 knots, 13 knots? Not that hard. What's your crosswind component on your airplane? Yeah. Where? Prove it. I would put a sticky note and tab it. We're now in section 5. It's up there on the top of the slide, 514. So 15 knots if you're full flaps, 20 knots otherwise. It's a very impressive airplane. Very respectful for crosswind. The Citation had 20 knot crosswind. It's a very, very good crosswind. Good on this, not that hard. Tomorrow we'll do one of those. Okay, now we're in real life. So your homework assignment was read the 1021 rule. Juan, I think it was you that said you do the 1021 rule. So the 1021 rule, and that's an EPIC procedure manual, page 64. At the beginning of this year, EPIC said, okay, you need to know what it is, but you no longer have to do it every time you flight plan. So what's the 1021 rule, Juan? Why do we have it?
You have to know the distance you need for normal take.
So why don't we use our performance?
Because there's store for long range.
Good. The wisdom of Cessna, they put only short field takeoff, short field landings. Very seldom do you do a short field takeoff, short field landing. So what does the 1021 rule mean? What is a 10 and the 21 referencing?
For each 10% increase or decrease on the rotation speed, you need to have 20%.
Runway. It doesn't matter if it's a takeoff or a landing. So when you look at your short field takeoff distance chart, liftoff is 51 knots if it's short field. Most of the time you do 55. So that's about 10% difference. So you add 20% more runway. EPIC just wants you aware of it, and your current's going to make a difference. In a 172, a whole lot of difference. Your instructor has you do it, that's great. You don't have to anymore. So pretty easy chart. Cessna makes their charts really easy. Piper does not. Pretty easy. The difficulty will be is if you can't do math and you have to interpolate. So we are at sea level. No, let's use the example I made up. We're at 5,000 feet. We're at Florida, 13 Celsius. So if we have to get over an obstacle, 2,975 feet of runway. Huge. If we're just rolling out, we don't have an obstacle, 1,705. Again, it's going to be interpolation. Because it's probably going to be something like 2,500 or something like that. This is, now we're not talking FAA written. Now we're talking check, write, and progs. This will not be on a FAA written. 1021 rule will not be on your FAA written. Real life. Be sure you always read the notes. Cessna always puts that 3,000 feet elevation in there on leaning your RPMs. Decrease distance 10% for each 9 knot of headwind. And increase 10% for each 2 knots. If you get to your prog and your check ride and you don't do that, not good. Do you see that? Dry grass runway, increase 15%. That you don't have to worry about, but this you do. How many have used this, maximum rate of climb? It's kind of like that other weight and balance, not accurate. Just be aware of it. So it's VY, pressure, altitude, estimated climb speed, and temperature. I've not had one student say they've used this one. They use this one. This is one of my favorites. I think Cessna did a really good job on time, fuel, distance to climb. How many have used this one yet? Get in navigation, you will. That's right, you probably haven't done this one yet because you haven't gotten into navigation. Most instructors do not use this one. This is better. Lots of details. We'll do this one in navigation. Really easy chart. You're going to have to interpolate. So now we have an airport at 3,000 feet. We're climbing to 7,000. The question is how long is it going to take us? So we're at 3,000, taking off at 3,000 feet. So 4 minutes, we're climbing to 7,000, 12 minutes. So it's going to take us a total of 8 minutes. If the question is distance, which is one of my favorites, 3,000, we have 6 nautical miles. 7,016 nautical miles, so 10 nautical miles. Really a great chart. Again, look at the details. We all know this one, engine startup, taxi. There's your standard lean above 3,000. Increase time, fuel, distance. Time, fuel, distance. 10% for each 10 degrees above standard temperature, because it doesn't have temperature here. It's not a chart for temperature. You almost always in Florida have to increase 10% for 10 degrees above standard temperature. We're just not 59 Fahrenheit or 15 Celsius. And 0 wind. The wind component we do on your nav chart. The temperature is important. And this is PIM 219. Another really good chart that makes sense. You're going to have to interpolate. Pressure altitude plus non-standard temperature is density altitude. So now you'll look at the chart. So it's recommended 75% MCP is horsepower. 75% horsepower. We have temperatures, pressure altitudes, RPMs. You're probably going to be given something during your check ride like 3,500. So you're going to have to interpolate. This is the one that if you plan on using an RPM and you put it on your nav log, you have to use it. If you don't use that RPM, it's going to change your fuel. You have to state it openly. Let's say you got to give it more RPMs to keep that altitude. Openly state, I'm increasing my RPMs to maintain my altitude, I'm going to be using more fuel. Recognize that you're not using the RPMs that you flight planned for. Good? Don't forget that. It's a really good chart. So MCP is the percent of power your airplane's putting out. Landing distance, same thing. Same thing as your takeoff. Same principle. Again, Cessna really does a good job. Pay attention. Decrease distance 10% for 9 knots of headwind. 10% for 2 knots of, let's see, am I saying that backwards? Tailwind. 10 knots of tailwind. We have the flaps here also. Gosh darn. No questions. How about your CX3? Do you want me to get Mateo for any questions on CX3? Otherwise, we'll do study buddies.